All right, so here is your video lesson about finding the domain. We'll mainly focus on the domain, finding the domain of a function algebraically. So here's some notes for you. When finding the domain of a function, ask yourself what values can't be used, and your domain is everything else. So there's two sort of simple rules to follow, and then everything else sort of falls under the hat of all real numbers. So the domain of all polynomial functions is always all real numbers, and we write that using this all real numbers, this funky little R right here. There are two main rules that we need to follow. One of them is when we have a square root, and the other is when we have a fractional function or a rational function. So looking at some examples down here, I'll let you read through some of these notes up here, but looking through these examples down here, I have this function right here, this function right here, and this rational function right here. So when I look at a function and I want to figure out what the domain is algebraically, the first thing that I want to ask myself is, does it have one of two things? Does it have a square root, and or does it have a variable in the denominator? So those are my two big rules there. So if I'm looking at this guy right here, I can see that I have x that's under the square root. So I know that my domain will be all real numbers, we'll start with that, and I know that I can't have any negative numbers underneath my square root. So my domain will be all real numbers, x values that are greater than or equal to 0, because I know that I can take the square root of 0. So all real numbers, x values that are greater than or equal to 0. And sometimes you'll see this domain is written as x values such that x is greater than or equal to 0. So this little line right here means such that. So you'll see domain written in a few different ways, and you should make yourself familiar with most of them. Over here, this second example that I have, f of x is equal to the square root of x plus 6, I want to ask myself those two questions. One, does it have a square root? And two, is there a variable in the denominator? And this falls into category 1. So I want to think to myself, what would make underneath my square root here? What would make underneath my hut a negative number? And I can think to myself, if I plug in 0, that will give me the square root of 6, which although is irrational, is still a positive number. I could plug in 5, that would give me 9. I could plug in -1, right? I can even plug in negative values for 6 here, or sorry, for x here, and that would still produce a positive value underneath my square root. So thinking here what I can plug in for x, if I plug in -6, that's going to give me 0. If I plug in -7, that is when I start getting into the negative values. So here, my domain will be x values such that x is greater than or equal to -6. I can't plug in anything less than -6. Coming over here, last example here, I want to ask myself those two questions. A, does it have a square root? No. B, does it have a variable in the denominator? So this last example falls underneath the variable in the denominator camp, or these fractional functions that we're talking about up here. So I know my big rule is I cannot divide by 0, so my domain in this case is x values such that x does not equal 0. Or sometimes you'll see this all real numbers, x is not equal to 0. So what value can it not be? Scrolling down here, there's just a few more examples. Here, f of x equals 2x squared plus 3x plus 6. I'm asking myself, do I have a square root? And do I have any kind of variable in the denominator? And the answer is no to both of those questions. So my domain here is x values such that x is an element of all real numbers, or my domain is just all real numbers. Again, there's a few different ways to write this. Looking here at g of x, going back to my big two questions, do I have a square root here? I do not. Do I have a variable in the denominator? And I do. So I want to think to myself, what could I plug in for this x here that would make that denominator 0? So what I want to do is I want to say, okay, x plus 3 equals 0. If I were to plug in, right, subtract 3 from both sides, x is equal to -3. If I were to plug in -3 here, that would give me a denominator of 0. So my domain is x values such that x is not equal to -3. Or x can be all real numbers, x not equal to -3. So that's a little bit about finding domain algebraically.